So we'll get it as mu naught I 4 pi a into integral of cos phi into d phi. So what is the value of cos phi that what are the limits I need to take? So the limits that I will be taking is, if suppose this is the value of phi, since I told it's a finite length conductor, if it is here, this value will be phi 1. If it is here, then this value will be phi 2. Okay, so the values will go from minus phi 1 to minus phi 1 to. So tell me, is there anyone who is having a doubt till this step?
Sir, can you repeat why dl by d phi is a secant square theta?
Where is it? dl by d phi. This one, huh?
Yeah, that.
Differentiated. So tan is secant square.
Oh, okay, sir. Thank you.
Yeah, that's. So is there any? Is everyone clear with why I took it as minus phi 1 and phi 2? Yeah, tell me.
Yeah, sir, but which part of the text is this?
Which part of?
The textbook is this?
This you don't have it in the textbook, but there is an often asked question.
Oh, okay.
Okay, yeah.
Okay.
So is there any doubt in the concept that I have explained?
Can you repeat why you took minus? Not clear what that is.
I will explain it. See, if I take the conductor to be like this, if this is dl, okay, if this is the length L, and if I take this point to be P, then if I take this to be phi, then this value, if I join from this point to the ending point, then see, phi is the angle made with respect to this horizontal. So what is the maximum value it can make in the clockwise direction? That is phi 1. Similarly, if I join from here to here, then the maximum value it can make in the the maximum value it made in the anti-clockwise direction is phi 1. The maximum value, let's say, it can make in the clockwise direction is phi 2. So that is why I took it as minus phi 1 to phi 2, because one of the directions of angles I considered as negative, the other one will be positive.
Okay.
Yeah. So integral of cos phi will be equal to sin phi. So sin phi from minus phi 1 to phi 2. Okay, this will be equal to mu naught I divided by 4 pi a into sin of phi 2 plus sin of phi 1. So this is the value of b. So are you clear with this? So b will be equal to mu naught I divided by 4 pi a into sin of phi 2 plus sin of phi 1. This is going to be the total magnetic field that is produced by the current carrying conductor of finite length. Okay. One thing I want you to clearly understand is this phi 2 and phi 1 are the angles that are made by the horizontal, that are made by the extremes of this wire at point P, near the point P. Okay. So this phi 1 and phi 2 are the point P where the field is to be calculated. So the angles you need to remember it like this. So the formula is mu naught I divided by 4 pi into sin phi 2 plus sin phi. Is it clear? So if it is clear, I will proceed to the next part. At least respond in the chat box. Is it clear? Okay. Now, special cases. When the wire is of infinite length. When the wire is of infinite length, I want somebody to tell me what do you think will be the changes that are happening with respect to phi 2 and phi 1?
Sir, phi phi 2 will be 0, phi 1 will be infinity. Will be 90.
Both will be 90.
So if I see, I have to take two cases here. So one will be the case when I'm taking the point P somewhere in between, somewhere at the midpoint. There is no midpoint for infinite length, of course. If I take it somewhere over here, then I told you when you join these 2 points, the angle made with the horizontal is phi 1. When I join between these 2 points, the angle made here is phi 2. So most of the questions are based on this concept only. Okay, they'll directly ask you the problems. So when I take phi 1, if it has to be infinite length, then where will this line and this dotted line meet? I'm taking this as first line. Where will the first line and the second line meet?
Sir, at infinity.
At infinity. So which two lines will actually meet at infinity? So what are the two lines which will actually meet at infinity? Technically, they are parallel lines. Right. So what should happen to the angle phi 1 so that it is able to meet this at infinity? Angle phi 1 should be
Pi by 2 degree radians.
pi by 2 radian. Similarly, phi 2 also should be how much? The same thing should happen with respect to 1 and 3 also. That should also be pi by 2. If I take these two and substitute it here, then what do I get? I get it as sine pi by 2 plus sine pi by 2. So you will get it as mu naught I divided by 4 pi a into sine pi by 2 plus sine pi by 2 is 2. So you will have the answer as mu naught I divided by 2 pi into a. This is a very, very important relation to be remembered. So mu naught I divided by 2 pi into a. So this is when you consider the point P somewhere in between. If suppose you consider the same point to be at one of the ends for infinite length, point P at one of the ends, then if I take the wire, if I take the wire like this, if I take the point P here, then what will be one of the angles and what will be the other angle?
0 and pi by 2.
Very good. So one of the angles will be 0 and the other will be pi by 2. So what will happen to the formula? Mu naught I divided by 4 pi a into sine of 0 plus sine of pi by 2. So the answer will be mu naught I divided by 4 pi a into 1. Right? So this is exactly half of this value, half of the previous results value. So this is another answer. So is it clear for everyone?
Yes, sir.
Right. So what I'll do is I'll write down all the formulae, okay, and I'll give you some problems. Let's try out some problems based on that. So what are the three formulae when you have a finite length wire here?
Sir,
Yeah, tell me.
sir, can you forward please? I want to copy.
Which one? This one, huh?
No, sir,
I'll
previous.
say this part.
Yes, sir. Thank you, sir.
Okay. Copy.
Yes, sir.
Done? Okay. So for this one, for the case 1, for finite length, the formula is B is equal to mu naught I divided by 4 pi a into sine of phi 1 sine of phi 2. Right. For infinite length, B will be equal to mu naught I divided by 2 pi A if P is in between. Same B will be equal to mu naught I divided by 4 pi A if P is at one of the ends. Okay, so keeping all these factors in mind, what we will do is we'll try to solve few problems. I hope you all made a note of it. So the example problem. Let's say there are two wires of infinite length which are having currents in the parallel direction I and I, and the distance of separation between them I take it as d. Okay. Now I want to find the magnetic field due to the whole system at point A, point B, and point C, which are at a distance of A, B, and C, like this. Okay. We need to find the magnetic field due to the whole system. When I say whole system, due to the first wire and the second wire along with the proper directions at point A, B, and C. And this is a very, very important problem because there are many concepts which are based on this problem, which we are going to discuss in the future. And the second question is, you have a square wire. 1 minute. You have four wires which are bent in the form of a square such that the current is flowing in it in the clockwise direction. The square is of side A. You need to find the magnetic field of the system at the point of intersection of its diagonals. So this is the second question. So this is the first, this is the second. I'll give you 5 minutes time. Just try the problem. Okay. After that I'll explain. At least you try looking at the formula.
Sir, both the wires are infinite length only, sir.
Yeah, both the wires are of infinite. So for infinite length, you know the formula.
done, sir.
Done. Anyone else?
Done, sir.
Yes, Shivatsan. Yeah. Yes, Shivatsan, tell me how to proceed.
Sir, at first we'll take A, sir.
Okay.
So,
Field at A. Okay, I'll write it. Yes. Tell me the steps. Okay, you're taking the field at A.
sir, for if you apply right and thumb rule for both the wires, first
Okay.
first B1, you will see
Mm-hmm.
that if you take that positive, B2 should be negative because that B1 will be inward and B2 will be outward.
Excellent. Good.
Okay,
So
so
B1 will be into the B1 will be into the plane and B2 will be out of the plane. That's right. Ah,
so then if you apply so total B is equal to B1 minus B2,
good. So what is the value of B1 then?
mu naught I by 2 pi A.
U naught I divided by 2 pi A. Can I put it as minus K cap here?
Uh, sir, oh yes sir.
So similarly, what is B2 vector?
Mu naught I by 2 pi into D minus A
Very good. D minus A.
K cap.
It is in the direction of K cap. That's right. So what is going to be the total field? B vector is equal to B1 vector minus B2 vector. That is going to be mu naught I divided by 2 pi A into minus K cap minus of mu naught I divided by 2 pi into D minus A in the direction of K cap. Someone else told they have completed. Is it Rohit?
Yes, sir.
Yeah, Rohit, tell me. So how do you calculate the field at B? Stevenson, good. How do you find
Uh,
it at B?
the field at B. Okay, so the field due to the first wire would be positive K cap.
Okay, what is going to be the magnitude of it? Mu naught
Mu naught I by 2 pi B.
2 pi B in the direction of positive K cap. Right. So if
Yeah.
anyone is not clear, for the sake of just one minute, if anyone is not clear, for the sake of understanding, if when the current is flowing in the upward direction, I told you in the previous class, if right hand side the field due to it is into the plane, on the left of it will be outward out of the plane. So that's what he's saying. Okay, there's going to be B1. Yeah, proceed. What is
And
B2 vector then?
B2 will also be in positive K cap, and
So mu
its
naught I
magnitude
divided by
2 pi times B plus D,
B plus D in the direction of
positive K cap.
good positive K cap. So what is going to be
So
the
then
total field? B vector will
uh,
be good.
uh,
B1 plus B2
1
vector.
plus
Yeah, how
B2,
much is it?
mu naught I by 2 pi times 1 by B plus 1 by B plus D.
Into K cap. This can be further simplified depending on the so however they give you the option, you can do it. Good. Anyone else at point C? Anyone who can tell me how to solve the point C? Rohit and Shiva, next one.
So can I?
Yeah, tell me. Is it Aditi?
Kritika.
Kritika, tell me.
Okay. So field at C, B1 will be mu naught I.
Okay, I'll write it here. Field at C, correct? Field at C, B1 will be equal to
Mu naught I by 2 pi into D plus C,
very good 2 pi into D plus C. What is the direction?
minus K cap.
Is going to be minus K cap. So what is B2 vector?
B2 vector will be mu naught I by 2 pi into C
Hmm,
in the direction of minus K cap.
very good. So total field will be B1 vector plus B2 vector. Since both are in same direction, they get added. So what will you get? Mu naught I divided by 2 pi into 1
Into
by D plus C.
1 by D plus C plus 1 by C minus K.
Very good. That's good. So you keep concept. My call got disconnected. Just a minute. Yeah. Anybody ready to solve this problem? We have solved the problem already. Srivatsan, Rohit.
Sir,
Yeah, Aditya.
sir, after this, would you mind explaining the first question again, because I didn't see it because my call got disconnected or something. Sorry.
Okay. Okay. See, I'll upload this recording anyways. Will that help? Because if I explain again, 5 to 10 minutes will get wasted.
Okay, sir. Sure, sir.
Yeah.
Okay, no problem. Thank you.
Yeah.
Thank you, sir.
Okay. Anybody? Srivatsan? Doing good. Okay. See, it's not that tough for you people to take so much time. Rohit, can you?
So can I try?
Yeah. Then.
Yeah.
You
So
can take a 10 minutes.
it's a square.
Hmm.
Yes.
It's
So
a
it
square,
will
yeah.
be nu naught by 4 pi.
So how do you want me to construct it first? How do you want me to reconstruct the diagram?
Sir,
So
because
I
it's a
will.
square. Yeah, you have to draw the diagonal.
Okay. So I will drop the diagonal. I'll join to these 2 points. If I take the free body diagram of this, how is it going to look like this thing? Right. Then this is going to be 45 degrees. Then this is also going to be
45 degrees.
45 degrees.
45 degrees.
So if I take this as the first conductor, magnetic field due to the first conductor is going to be what? Mu naught I
Nu naught by 4 pi
4 pi.
I. Nu naught by 4 pi I.
Huh?
2 by a root 2. A by 2.
No, first tell me. It is a by 2. Good. A by 2 into sine of.
Sine 45
Very good.
plus sine 45.
Sine 45. So now we have completed the scalar part. How do you convert it to the vector part? I put a vector symbol. How do I convert it to vector part?
It's minus k cap.
Very good. It is minus k cap. Right. Similarly, what is going to be the value of B2? Mu naught I divided by 4 pi. Yeah, Kritika, proceed. Hello.
Yes, sir, just
The same thing. It's the same thing. Mu naught I divided by 4 pi into what is going to be the distance? A by 2 into sine 45 degrees plus sine 45 degrees. But the only thing I'm concerned about is find the direction in there.
k cap.
Why do you feel it is k? See, I know this
It's
confusion.
going to be
Sorry, it's minus k.
It is minus k. Okay, see, this confusion. Here, what you can also. So, if I take this to be the direction of current, if I take this to be the point, then this is r vector. So, r vector is always from the conductor to the point. Okay. Then dl vector cross r vector gives you the direction of magnetic field. In this case, in this particular diagram, what is the value of dl? What is the direction of dl vector? It is j. It is I cap. So what is j cross I? It is going to be the reason why you have a minus here. Similarly, if you try for the other things, also you will get a minus sign here. So this is B2 vector. Similarly, B3 vector will be equal to mu naught I divided by 4 pi into A by 2 into the same sine 45 plus sine 45 in the direct minus k cap. Similarly, B4 vector will be equal to mu naught I divided by 4 pi into A by 2 into sine 45 plus sine 45 in the direction of minus k cap. What will be the sum of all the values? B vector plus B2 vector plus B3 vector plus B4 vector. Then what is going to be? Mu naught I divided by 4 pi into A by 2 into sine 45 plus sine 45 is root 2. So the answer will be, here there is a 4, so 4 and 4 will get cancelled. You will have it as 2 root 2 mu naught I divided by pi into A in the direction of minus k. This is the required answer.
Sir, can you explain why k is
My case,
minus in B2?
my case minus in B2. Okay, listen. So for B2, what I did is, when you apply the right hand thumb rule, see, if you observe, this is the direction of current, right? So place the thumb of your right hand in the direction of current and try to curl your fingers. Place the thumb of your right hand in the direction of current and curl your fingers.
Yes, sir.
You are getting it into the plane on the right of it.
Yes, sir.
That is the reason why I wrote it as minus k cap. See, there is another way to analyze this. That is what I told, the vector method. So when I take the vector method, it is going to be like this. dl, and this is going to be r vector. If I take this to be the point, see, dl vector is to the right. So when I do dl vector cross r vector, what is dl? I cap cross r vector is minus j cap. So I cross j is k cap, with a minus sign is going to be minus k cap. So this is the answer. This is another way to analyze. Okay. So throughout this chapter, this dl cross r will save you. Okay, that is why this answer came out to be 2 root 2 into mu naught I divided by pi into a. So this is the final answer. Any doubt in this? Are you done with this? So I'll give you one more problem, do it. Why none of you are responding?
Yes, sir.
So if I take 3 wires of equal length and place them in such a way that they form the vertices of an equilateral triangle of side A, we need to calculate the magnetic field due to the system at the centroid. Find the field due to the given system at the centroid. Can someone tell me how to proceed? Siddharth, can you try? I don't mind even if it is wrong. I just want somebody to try.
So
Sir, what
answer.
centroid, sir?
Your voice is
Yeah.
there. There's too much of noise, Siddharth.
Sir, I finished.
Sir,
Keep the mic away, no? Keep the mic away.
sir,
Now it is better. Tell me.
sir, we can first draw the median, sir.
Okay. So for an equilateral triangle, so what do you mean by centroid? Centroid is a point of intersection of medians. So for an equilateral triangle, what are the property? The median, the angular bisector, and the altitudes. All are the same.
Sir.
So when you drop them, so this is the way you are going to draw the median. So when you draw the median, it is also going to be angular bisector. Good. Then what are you planning to do?
Sir, we can extend the median, sir.
Medians have
We can extend.
Sir, we can extend the median, sir.
Okay, we can extend the median.
So don't the medians have like a property of they cut in the ratio of 2:1 or something like that?
That is this one, 2:1 here. That is a centroid.
Sir,
That
as
is not.
We couldn't use that.
We did not use them
Okay.
because see for those
So the
just a minute,
median,
Siddharth.
median is the
For those who ask the question we need not use it because for you to apply this formula, you only need to know the angles. You're not concerned about the ratio. That is the reason you need not use. Yeah, Siddharth, tell me.
sir, as medians are perpendicular bisect on the sides, sir,
Okay.
in an equilateral triangle. So we can take
A by 2, this is 30 degrees. Then this distance will be how much?
R, sir.
So, y divided by a by 2 will be equal to tan 30.
Yes, sir.
So, y will be equal to a divided by 2 root 3. So, is that what you're trying to say? So, this 2 root 3, how much is this angle? 60 degrees?
60
And
degrees.
this angle? 60 degrees. So, how to apply the formula? If I take the bottom one to be the conductor, the first conductor, B1 will be equal to mu naught I divided by
4 pi
4 pi into a by 2 root 3 into sine of 60 degrees
and 60 plus
sine
60.
direction
Dash minus k cap.
minus.
Minus k cap.
That's it. Okay, can mute yourself. So this is B1 vector. Similarly, what will be the value of B2 vector? From the symmetry, we can say it is going to be mu naught I divided by 4 pi into a by 2 root 3 into sine 60 plus sine 60 is 2 root 3 divided by 2, that is root 3 in the direction of minus k cap. And B3 vector will also be the same thing, mu naught I divided by 4 pi into a divided by 2 root 3 into root 3 in the direction of minus k cap. So what is going to be the total magnetic field? It is going to be 3 times mu naught I divided by 4 pi into a divided by 2 root 3 into root 3 in the direction of minus k. So this will be 3 root 3 into mu naught I divided by 2 pi a in the direction of minus k. That's the answer.
Sir, can you explain how the distance is a by 2 root 3?
so it's 9 by 2 pi.
9, huh? Why is that? What? Oh, this root 3 is there. Sorry, I missed it. Thank you. 9 mu naught by 2 pi. Yeah, for those who ask me, how did I take the distance? If I take this distance as y, this will be a by 2. This 30 degrees. So y by a by 2 will be equal to tan 30. Tan 30 is 1 by root 3. So y will be equal to a divided by 2 root 3. Here?
Sir, it's an equilateral triangle. Should be 60 degrees, right?
It is an angular bisector. So the
So
one which
that
is joined,
vertex will be 60 degrees.
which one should be 60? You're talking about this one.
That will be 30 degrees. The other one will be 60 degrees.
No, no, no. See, what I'm trying to
Sir, I
do
have a
is,
doubt.
1 minute. I'll come to the. See, please understand, this is how the medians are.
The triangle within the triangle.
This is a triangle within, I've taken this triangle. I'll use another color observe. I've taken this triangle. Okay, that triangle is what I wrote like this. Then when I drop a perpendicular, this will be a by 2, this will be y, and this will be 30 degrees. Are you clear now? Because I want to know this distance, I want to know the perpendicular distance from the conductor to the point where I'm calculating the field, the point centroid. So I need only this distance. This distance is y, this distance is a by 2, this is 30 degrees. Here, there's somebody told they have a doubt.
Sir,
Got
I
it,
have.
sir.
Sorry?
Sir, in the formula, like it should be sine 30 plus sine 30 here, not sine 60 plus sine 60.
Why sine 30 then? Why sine 30?
Sir, because the side it makes an angle with the centroid, it's the 30 degree only.
Why I don't understand why you're saying that. This is the angle. No? I told you, you need to be careful with the angles. Angle made near the point. So if this is 30, this is already 90, then how much will this be? This is going to be 60, no? So this is 5, if this is 5-1, Varun, you're able to understand, if this is 5-1, this is going to be 5-2.
Oh, you're taking that angle.
No, I am not taking, that is what the formula says. That is why it's test on that point, you'll make this mistake. See, again, I'm repeating it, I'm going to the diagram. See, the angle is taken near the point where the field is to be calculated. This is 5-1 and this is 5-2. That is how the derivation is.
Okay, sir.
If at all you want to take these angles, then it will be in terms of cos. Might be there are some books which will give you as cos theta 1 plus cos theta 2. You should actually look at what are the angles, don't memorize the formula. Okay, I hope this is clear. Anyone else? Any doubt?
Sir, if you take the perpendicular distance as root 3a by 6 and sine 60 plus sine 60, you get the same
Root 3.
answer.
Root 3a by 6. So why should I take root 3a by 6?
The perpendicular distance from the centroid to the side.
So a by 2 root 3 rationalized it. You just multiply the numerator and denominator with root 3.
Yeah, and then you took sine 30, sir. I didn't understand why you took sine
Where
30.
did I take sine? Where did I take? I never took sine 30. I took tan 30.
Okay, yeah.
This is a right angle triangle, no? In this right angle triangle, if I ask you what is tan 30, it is opposite by adjacent. That's what I wrote. Nothing else I did.
Okay, sir, got it.
Got it? Anything else?
Clear, sir.
Here? Okay. So this is all about the application of Biot-Savart law for a finite length conductor. Actually, there is another topic that is to be discussed. See, from next class onwards, I'll go a little fast. Since this is the second class, I'm going this slow. First thing I want you to speak, or else if you're not speaking, there is no point of just having this class. I will record and give you the videos. You sit and watch whenever you feel like. Listen. So this is the next topic we are going to discuss. Magnetic field on the axis of a circular current carrying loop. This is very, very important. Okay, for you to understand, the reason I didn't start this is because this needs a little bit of visualization because it is going to be in 3 dimension. Once you're comfortable with the integration, it and be ready. Next class onwards, I'll go a little fast. I'm going to do at least 2 subtopics, 2 to 3 subtopics. I'll finish it per day. Today I could finish only 1, and problems your people tortured me like anything. without opening your mouth.
Sir, when will be the next physics class?
Next Monday.
Okay, fine.
Yeah. I'll come up with a new schedule. I've gone through all your